Right, your body does about 100 weird things every day that you've just accepted. You blush, you yawn, you get pins and needles, you can't tickle yourself, and nobody's ever sat you down and explained any of it. So that's what this is. 10 things your body does, and what's actually happening when it does them. Some you'll be glad you know. The last one is, in my opinion, genuinely beautiful. You get goosebumps when you're cold, or scared, or hearing a song you love. Why is your body doing exactly the same thing in 3 completely different situations? Every hair on your body has a tiny muscle attached to it. It's called the erector pili. When you're cold, that muscle contracts and pulls the hair upright. In an animal with proper fur, that traps a layer of warm air against the skin. Genuinely useful insulation. The problem is, we don't have proper fur anymore. We lost it about 2 million years ago. But we kept all the muscles. So now they fire pointlessly and make our skin look like a plucked chicken. The fear version is the same system. Sympathetic nervous system fires. Fur stands up to make you look bigger to predators. Bigger to predators. Look at us. Speaking of your body embarrassing you for no reason. Blushing. You blush when you're embarrassed. You can't stop it. You can't fake it. And as far as we know, you're the only animal on Earth that does it. Darwin called blushing the most peculiar and most human of all expressions. Here's the mechanism. When you feel social embarrassment, your sympathetic nervous system fires, the same one behind fight or flight, but instead of just speeding up your heart, it tells the blood vessels in your cheeks to open up. Blood floods in, you light up. The weird bit is the why. Most fight or flight stuff is private. Your heart's racing, but nobody can see it. Blushing is the opposite. It's the only involuntary signal specifically designed to be visible. The leading theory, it's an honest apology, an unfakeable, I know I've messed up. Humans are social enough to need that. Your body's also got a way of telling you when something's properly wrong, like when you've been sitting on your foot. You've been sitting weirdly, you stand up, your foot is now made of static electricity. What is actually happening? It's called paresthesia. The pop science answer is your foot fell asleep, which is sort of true and completely useless. What's really happening is you've been pressing on a nerve. Not cutting off blood, pressing the nerve itself. Nerves don't like being squashed. The signals they send to your brain get distorted, or they stop sending altogether. When you finally stand up and the pressure comes off, the nerve doesn't just go back to normal. It sends a chaotic burst of misfires. Your brain interprets that nonsense as tingling, prickling, that weird ant under the skin sensation. It's not damage. It's a nerve rebooting, which is why moving the leg makes it worse before it gets better. You're loading a freshly booted nerve with new traffic. Speaking of your body doing things you didn't ask for, yawning. You're not tired? Someone yawns? You yawn? They didn't ask. You didn't decide. Why is this contagious? First, the awkward fact. We don't actually fully understand why we yawn at all. The old your body needs oxygen theory has been disproven. Blood oxygen doesn't change when you yawn. The current best theory is brain cooling. A big inhale pulls cool air over the blood vessels feeding the brain, and brains work better cool. That's why yawns spike when you're tired, bored, or shifting between mental states. The contagion bit is stranger. It tracks with empathy. People who score high on empathy tests catch yawns more often. Children with autism catch them less. Dogs catch yawns from their owners. It's not a reflex, it's a quiet social mirror. Your brain is checking that you're still in sync with the group. Another reflex you absolutely cannot stop: sneezing. A sneeze leaves your face at about 100 miles an hour, and your body chose to do that. It's not a malfunction. A sneeze is a controlled explosion. When something irritates the lining of your nose, dust, pepper, pollen, sensors fire a signal up to a region of your brainstem literally called the sneezing center. That center choreographs about a dozen muscles in sequence. Deep inhale, glottis closes, chest pressurizes, glottis snaps open, blast. The whole point is to clear the airway faster than anything you could do voluntarily. By the way, the myth that your eyes will pop out if you sneeze with them open, not true. Your eyes close because the same nerve that triggers the sneeze also triggers the eyelid muscle. They're wired together. And the strangest follow-up, about a quarter of people sneeze when they look at a bright light. Nobody fully knows why. Your body does loads of things automatically, including something it absolutely cannot do to itself. You can tickle other people. Other people can tickle you. You cannot tickle yourself. And the reason why tells you something quite deep about your brain. There are actually 2 kinds of tickling. The light ugh, stop kind on your forearm, that's called nismesis. The I can't breathe, please no kind on your ribs, that's gargalesis. Only the second makes you laugh, and only the second is the mystery. When you try to tickle yourself, a part of your brain called the cerebellum predicts the sensation a fraction of a second before your hand arrives. Because the prediction matches the input, your brain dampens the signal. You feel it, but barely. When someone else does it, there's no prediction. The signal arrives raw, that's why it's overwhelming. The cerebellum is basically your brain's what's about to happen next forecaster, and it forecasts your own hand correctly every single time. Speaking of your brain knowing things you don't, hangovers. You wake up after a heavy night feeling terrible. Most people will tell you it's dehydration. Most people are wrong. Dehydration plays a small role. Alcohol suppresses a hormone that normally tells your kidneys to slow down so you pee more. But if dehydration were the main villain, a few glasses of water at bedtime would fix everything. They don't. The real culprit is a chemical called acetaldehyde. Your liver breaks alcohol down in 2 steps. Step 1 converts alcohol to acetaldehyde, which is significantly more toxic than alcohol itself. Step 2 breaks acetaldehyde down into something harmless. If you drink faster than step 2 can keep up, acetaldehyde accumulates. That's what poisons you the next morning. The headache, the nausea, the strange sense that gravity has doubled, inflammation, sleep disruption, gut bacteria, they all contribute. But acetaldehyde's the headline act. The water helps. It just isn't the cure. While you're recovering, your brain is doing something properly strange every single night. You sleep for a third of your life. For most of history, we had no idea why. Now we sort of do, and it turns out your brain is being literally washed. In 2013, a researcher called Mike Nedergaard discovered something called the glymphatic system. When you fall asleep, the cells in your brain shrink by about 60%. That opens up channels between them. Cerebrospinal fluid, the clear liquid that surrounds your brain, flows through those channels and rinses out the metabolic waste that's built up during the day, including a protein called amyloid beta, which is the same protein that accumulates in Alzheimer's brains. So sleep isn't just rest, it's a physical cleaning cycle that cannot run while you're awake, because there isn't space for the fluid to move. Chronic poor sleep doesn't just make you tired, it leaves the rubbish in. Your brain's bin men only show up at night, and while it's washing itself, it's also making films. You spend about 6 years of your life dreaming. Nobody fully knows why. But the leading theories are all more interesting than your brain's bored. There are 3 serious contenders. 1, memory consolidation. During REM sleep, your brain seems to replay bits of the day, strengthening some connections and pruning others. Dreams might be what that replay feels like from the inside. 2, emotional processing. The parts of your brain handling fear and emotion go full throttle during REM, while the logic department is dialed right down, so your brain rehearses emotional stuff in a low-stakes simulator. 3, and this one's a bit unsettling, threat simulation. Some researchers think dreams evolved as a training ground for danger. Notice how often dreams involve being chased, falling, losing your teeth. Could be coincidence. Could be your brain practicing survival in safety. The honest answer is probably all 3 at once, plus a generous helping of random neural noise. Last one, and it's the most beautiful thing your body does without telling you. Right now, somewhere inside you, your body is checking the identity of every single cell against a list. Anything that fails the check, it kills. Almost every cell in your body wears a molecular ID badge on its outer surface. It's called MHC, Major Histocompatibility Complex. Inside the cell, MHC grabs little chunks of whatever proteins are floating around, yours, viral, bacterial, anything, and pushes them up to the cell membrane like a display case. Your immune system has cells called T cells, whose entire job is to walk past every cell in your body and read those display cases. If they see your normal proteins, they walk on. If they see something foreign, say a viral protein, the cell's been infected. They kill it, every cell, every minute, all day, all night. Trillions of inspections a day. You are alive right now because that quiet identity check works. And almost nobody who isn't a biologist has ever heard of it. Worth knowing. That's 10. Your body's running thousands of these little subroutines while you've been watching this. If you want me to do another batch, kitchen chemistry maybe, or things in space you've stopped questioning, leave a comment with which one. Cheers.